In this video, we're going to talk about the multiplication and division of rational expressions. Let's first start with multiplication. When we look at multiplication of rational expressions, remember your rational expressions are expressions that are division of polynomials, right? So we have fractions. And basically, since we already know how to multiply and divide fractions, we're going to use those same techniques and apply it to these rational expressions here. For instance, a multiplication of a regular fraction or two regular fractions like 3/5 and 10 over 21. What we normally do to multiply these fractions, or one technique to multiply them, is to cancel the common factors. For instance, 3 and 21 have a common factor of 3, so we can simplify those, right? Cancel those common factors. And 5 and 10 have a common factor of 5. 5 goes into itself one time, 10 goes into itself twice. 5 goes into 10 twice. And so we've canceled the common factors. Now we're going to multiply across. So I have this 1 right here times this 2, which we get as 2. And a 1 times 7 in the denominator, which is 7. We're going to use these same techniques to help us multiply rational expressions. Notice that we're going from two fractions to one fraction that is completely simplified. All right, that's when we know we can stop. For those of you who like to write steps, these are some steps that I'm going to take when we have these rational expressions. Same kind of technique as with the numbers, except we have variables, we have polynomials. All right, the first thing I'm going to do, in order for me to cancel, I have to have everything in multiplication. For instance, if you look at this example here, I have addition and subtraction between these terms here. I don't want that to happen. And so I'm going to have to factor all of my numerators and denominators so that I can have multiplication. Because I can't cancel until I have all multiplication. After I factor, I can cancel my common factors, and then we'll multiply across like we did the 1 and the 2 and the 1 and the 7 in that numerical example. Let's look at this example here. We have these two rational expressions, all right? In order to multiply these simply, all right, what we're going to have to do is factor everything. So if I look at my numerators, all right, if I have an x plus 2 and an x minus 1, that'll be the same thing as that one up there. I can factor this denominator, a minus 5, a plus 1. And then I'm going to go to my numerator to the right. That's kind of already in factored form. Unless you want the x to be first, you can factor out the negative and it'll be its opposite. And in this denominator here, x plus 9 times x plus 2 works. Okay. Now that we have everything factored, hopefully a lot of stuff will cancel out, right? For instance, my plus 2 disappeared. These x plus 2's here, they cancel. All right. Notice you can only cancel when things are on the numerator and the denominator. You can't cancel two things that are on the same numerator or same denominator. All right. But if we think about it, that's the only thing that cancels here. These two look like they might be able to be canceled, but they're not opposites. Remember, opposites, the order is just switched. Both have to be subtraction. So that's the only thing that cancels here. And so now we're ready to multiply across. So my numerator is now going to become x minus 1 times 6 minus x all over x minus 5 times x plus 1 times x plus 9. Notice we went from two rational expressions to one rational expression that is completely simplified. And we can leave our answer or our product like that. Let's look at some more complicated examples or some more interesting examples. This example here, we have a couple of functions, all right? So we have f of x and g of x, and this symbol here, that's the multiplication symbol. That's telling us that we want to find the product. F of x times g of x. Well, all I have to do is multiply them. Now, to save me some space, some paper, some time, I'm going to go ahead and factor, right? I know I'm going to multiply, put the expression here, but I'm going to have it in factored form. That 49 minus x squared is a difference of squares. The 7 plus x times 7 minus x. I'm going to go over here to g of x because I'm multiplying f of x by g of x, and I'm going to factor both the numerator and denominator as well. X minus 7 times x minus 3. And the denominator factors into an x plus 4 times an x minus 3. So we've completely simplified this. If you wanted to, you can put this in parentheses. It's not necessary. But now we have everything factored. Now we can cancel our common factors. For instance, an x plus 4, both on numerator and denominator. X minus 3 on both the numerator and denominator. And if you look, we have some opposites here. Okay. As always with opposites, in order for us to cancel them, we have to factor out a negative out of one of them. All right, so let's say I chose this one here to factor out a negative and write it as its opposite. Once I do that, now I can cancel. And remember, that negative does not have to go on the denominator. You can put it in the numerator. Or you can put it on the outside of the fraction. I'm going to stick with putting it on the outside of the fraction. So I'm going to have a negative. If you notice, all of my terms, or my factors on the numerator canceled. When that happens, there's a 1 on top of your numerator. All right, remember, when you divide something by itself, it's still equal to just 1. So it's not going to be a 0 here like a lot of people think. It's just going to be a 1. And the only factor that's in my denominator, this one's already gone, right, is that 7 plus x. And so this is now one fraction. It is completely simplified. And we're done. We get a negative 1 over x plus 7, or 7 plus x. Also, remember here, with addition, the order doesn't matter. So if you wanted to write x plus 7 instead of 7 plus x, that's perfectly fine, right? Addition, the order doesn't matter. But with subtraction, it does. That's why we go through this whole process with these opposites here. All right, let's get to division of rational expressions and functions. Division is going to be very similar to division, what we have with regular fractions with just numbers or integers in the numerator and denominator. And so we're going to use those same techniques. Let's review that. In order to divide by a fraction, we multiply by the reciprocal. Okay, so we have 2/3, change that division to multiplication. And the reciprocal of 16 over 9 is 9 over 16. And there's that word again, reciprocal. It means to do 1 over that thing, which is the same thing as just flipping the fraction. All right. Now that we have this, this is now a multiplication problem. So we would carry on just as if this was a multiplication problem. We look at 3 and 9, they have a common factor of 3. We look at 2 and 16, they have a common factor of 2. Once we have those common factors canceled, we can multiply across. Our solution will be 3/8. Okay, so there's only one extra step with division that's different from multiplication, and it's that very first step. And that step is to change division to multiplication by multiplying by the reciprocal. Okay, and so this is what we're going to use here in order to help us do these division problems. Let's look at a couple of examples. This example here, x squared minus 2x minus 35 over x squared minus 15x plus 36. We're going to divide that by that second rational expression there. All right. Again, in order to do that division, we'll keep our first rational expression exactly the same. But what we do is we change division to multiplication, and we do the reciprocal, which an easy way to remember is to flip that fraction, the second fraction. Okay. And there we have it. Now this is a brand new multiplication problem. So as we continue forward, right, continue as if we were beginning with this multiplication problem right here. We're going to factor all the numerators and denominators. So I have x here, a minus 7 and a plus 5 will both work. In this denominator, x minus 12 times x minus 3 is how we factor that. And at this point, you want to get really good at factoring because it'll make your life so much easier. A positive 11 and a minus 3 will work. And in this denominator here, x minus 7 times x plus 6. Okay. So everything's factored, and now all we need to do is cancel our common factors. All right, so if you look, x minus 7, x minus 7. I have x minus 3 here, cancels with that x minus 3 there. All right, and so those are the only things that cancel, so we are ready to multiply across and write everything as one single fraction. I have x plus 5 times x plus 11 all over x minus 12 times x plus 6. All right, so note we went from having two rational expressions being divided to having one single, completely simplified rational expression as our final answer. And there we have it. Let's not do that. All right, so this is our answer here. Let's look at another example involving some rational functions. This time we have f of x and g of x. Again, this is the functional notation that I'll give you from time to time to help you simplify or do these divisions here, these operations. All right. When I do f of x divided by g of x, I'm going to take f of x and divide it by g of x. But remember, when we divide, we multiply by the reciprocal. All right, so instead of rewriting it as the division, I'm going to go ahead and multiply by the reciprocal. And now all we need to do is to factor. Now, I'm going to factor this probably pretty quickly, but I would hope that you would take the time to factor it on your own. For instance, you can use the method where we multiply the 3 and the negative 5 together to get negative 15, and then we'll rewrite this middle term. Right? And you can use that same method on our denominator here so that you can get that middle term, and then you can factor by grouping. All right, once you're done, you should get a polynomial or two binomials in our numerator, 3x minus 1 times x plus 5. And in the denominator, you should get the binomials 2x minus 3 times x minus 4. I have a difference of squares here on my numerator, so I have 4 plus x times 4 minus x all over x plus 5. And now everything is factored. So my goal is to cancel our common factors now. I have an x plus 5 here and an x plus 5 here. And if you look, we have some opposites here. And so what I'm going to do is I'm going to factor out the negative out of this opposites here, these opposites here. So this is going to be a negative x minus 4. And now that I factored out that negative, I can cancel these two opposites here. And so I'm going to be left with, after I multiply, I can bring that negative on the outside of this rational expression. And if I multiply across, I get a 3x minus 1 times a 4 plus x. Again, if you're more comfortable with writing that x first, you can, because this is addition. And this x plus 4 here, 4 plus x. And my denominator is just going to be a 2x minus 3. And this would be our solution here. Completely simplified. Okay, one fraction completely simplified. Let's look at one last example. It's a little different, so I do want to cover an example that looks like this. I have function notation again, so we're going to do the same thing as we did in the last example. But this one looks a little different because I'm dividing a rational expression by a whole looking thing, right? It's a polynomial. It's not a fraction. But we use the same methods as if we had a fraction, right? For instance, if we had 1/2 divided by 3, right? Then what we do is we multiply by the reciprocal, right? If something does not look like a fraction, we can always make it look like a fraction by putting it over 1, dividing it by 1. And so now we have the insight, or we can easily see that, hey, we keep our first number, we change that division to multiplication, then we do the reciprocal of that third of the second number, which we wrote as a fraction, and so that would be 1/3. And so in this case, when we have g of x, we can write it as x squared plus 3x minus 28 over 1. And that way we can see our reciprocal is 1 over that actual x squared plus 3x minus 28. So when we come to do this division, or to perform that division, we'll keep this the same, f of x the same, the expression for f of x. And then we're going to multiply it by the reciprocal, which will be 1 over x squared plus 3x minus 28. And now the rest is just normal as we normally would, right? We factor this into a x minus 4 times an x plus 3, all over in x plus 7, times 1 over x plus 7 times an x minus 4. And now everything is factored. We can cancel our common factors. X minus 4 are in both the numerator and the denominator. And that's all that cancels, right? We can't cancel these x plus 7s because they're both in the denominator, so don't try to do that. And as we write our solution, well, x plus 3 times 1 is just x plus 3. And in our denominator, we have an x plus 7 times an x plus 7, which we can write as x plus 7 squared, right? Remember that if you multiply something by itself, it just equals that thing squared. So instead of writing x plus 7 times x plus 7, it's a lot quicker to write x plus 7 squared. And so here is our solution. Again, we have one rational expression as our answer, and it's completely simplified. So we know we can stop there. All right, this concludes our lesson on multiplying and dividing rational expressions.